In this section, we'll go over different demonstration options for the TEC Trainer. We'll cover the blower door test, the basic blower door test, the total duct leakage test, and duct leakage test to the outside. And we'll show other devices that you can demonstrate in front of a class, such as the exhaust fan flow meter and the flow blaster. And then we'll talk about some options of discussing the use of multiple TEC trainers, where you could do a zone pressure diagnostic demonstration or demonstrate some testing of townhome units. The recommended configurations, because the TEC Trainer has a small volume and the airflow through it becomes quite turbulent. We did some extensive testing on it to come up with the best testing option, so you can test in a somewhat repeatable way that limits the air currents through the TEC Trainer. So for a 1-point CFM50 test, either pressurization or depressurization, it's best to either have the 3 holes all the way open, 2 holes all the way open with the back hole sealed. So if you're choosing 2 holes, close the back one and fully open the other 2 holes, or if you're going to test with just 1 hole open, you can fully open any of those other holes. We found that's the best for a repeatable test. It's not that this is the only way you can test it, but we found it limits the turbulence throughout the system and turbulence in the area where you're taking the measurements if you use one of these configurations. For multi-point testing, so if you're doing a multi-point testing, if you're demonstrating the TEClog software or the TECtite software, we recommend having either all 3 holes open or any one of the other holes open for a pressurization test. If you're doing a depressurization test, it complicates things more, because now the fan is turned around and what you see from the outside from the classroom is the grate on the fan, the back side of the fan, and the flow sensor is inside the fan, and there's some turbulence associated with that, and that seems to work best with just 1 hole open. And then there is a range. This information is in the manual. I'm not going to spend a lot of time on it, but with 3 holes open, you can expect 700 to 800 CFM50. 2 holes open, 500 to 575. 1 hole open, 250 to 325. So that's kind of the range that you'll see when doing those tests because of the turbulence within the trainer. So the first step, you'll install the blower door frame inside the opening, install it to size, install the panel over it, and then install the framing in there for a pressurization test. Now you notice this is what you would typically see when you're setting up a blower door inside the house, but the enclosure is inside the house, so it is a little bit different, where this is really simulating setting up a blower door at the front door of a home, and that would be a method that might be used when you're testing an individual apartment unit or condo unit. If you might want to set up in the hallway, and that makes it easy to move from one unit to the next. Just loosen the cams and pull it out of the opening and walk down the hall to the next one, and using maybe a Duct Blaster fan instead of a blower door fan, so it's lighter. So that, or when doing townhome testing, oftentimes it's easier if maybe you're testing 3 or 4 units at a time, and it's easier to go from blower door to blower door if you're set up on the outside. So that's really what this is simulating, is setting up the fan on the outside and doing a pressurization test. Then we'll install the gauge mounting board and the gauge. The next step will be to connect the tubing, and there's on each side of the TEC Trainer, on the upper corners on the side, is a green patch and a bulkhead. So the brass nipple, like you see on the gauge, will be sticking out there to allow you to connect the tubing up. So we'll connect the green tubing to that side, and then to the fan we'll run our red tubing. And then so we're all set up. We'll want to set our leakage adjustment windows, how we want to set that up, and then we'll want to close the zippered opening when we're doing the blower door test. So for conducting a 1-point pressurization test, if we have 2 or 3 holes open, we'll use ring B. If we have just 1 hole open, we'll use ring C. And if you want to make it look like a more realistic test, you can run a hose to the outside, going to the reference on channel A. So you'll actually have an enclosure with reference to outside, and that'll give you a more realistic baseline reading if you want to do that. And then follow the standard test procedures that you would for just a standard blower door test. Some other blower door test options: you could use the cruise control feature of the gauge and demonstrate that. You could conduct an automated test using the TEC software, a multi-point test, or a ResNet single point, ResNet multi-point, ResNet repeated single point test. Or you could use the DG700 simulators I talked about before. So you could connect the gauge to your computer and broadcast the gauge up on the screen. And then that you use your mouse and push the buttons up on the screen on your computer to use the simulator. So the gauge buttons on the gauge itself aren't functional anymore. The computer takes over, and you can control it from the computer. And to connect the gauge to your computer, we do have a 9-pin and RS-232 to Cat5 adapter that you would use, and then you could run any length of Cat5 cable. If the trainer is set up quite a ways from where your computer is set up, you can run any length of cable. And we successfully run up to 5,000 feet of cable and not had any problem with the signal. And then on the other end, you'd have again a 9-pin to Cat5 adapter, and then a 9-pin to USB adapter, and you can get those through the Energy Conservatory. We do also have a new Wi-Fi adapter that'll be available in June of 2013, and that would allow you to connect wirelessly to your computer. Duct leakage testing. You can do the total duct leakage outside, and either pressurization or depressurization for the duct leakage testing. So first step will be you'll open the zipper in the back, and you'll attach that flex duct to the inside of the trainer, and that attaches to Velcro on the sides of the container there. And then you'll connect a short length of blue tubing from the duct to that blue patch, the bulkhead on the blue tap. So you'll connect to, just like those of you who have a Duct Blaster fan, you'll be familiar with that tubing array with the T connection. You'll connect the blue tubing, short piece of blue tubing, to that T, and then to the this is a double-sided brass tap, you'll connect to the tap inside the trainer with that short piece of blue tubing. Then we'll install the white attachment plate on the outside of the enclosure. First step will be we'll remove that leak adjustment window, and then we'll line up the white attachment plate and connect that with the Velcro. And you'll remember on that earlier picture, there's two sets of the hook Velcro on that where the white attachment plate will connect. So you can open that back zippered opening and make sure you get a tight connection on both of these sections. Then we'll install the gauge mounting board for the Duct Blaster and the blower door, and we'll attach the Duct Blaster board on the side with the white attachment plate, so we're on the same side that the Duct Blaster fan will be, so our cord connection will reach there. You'll notice that Duct Blaster controller, this is our newer controller. It's been out for just over a year. It has a cooling fan that the other controller did not have, and then it also has that audio tap on the side for connecting your cruise, your fan control cable that gives the Duct Blaster a cruise feature, which is a nice feature to have for that. Next, we'll connect the flex duct. We'll connect the square transition piece for the duct with your Duct Blaster system. We'll tape that to the white attachment plate, and then we'll attach the flex duct to that square transition piece. Next, we'll set the leak adjustment window. So this is on the opposite side of the white attachment plate we have, and this will adjust the duct leakage to outside. So this is the connection between that ductwork and the outside, and that's adjustable. And the recommended settings for this is either have it 1 inch open, 4 inches open, or fully open, are the three options for your leakage to the outside to get the best, most repeatable readings. And then this is a view from the inside where you'll see, and during the total duct leakage test you don't have to have the blower door installed. You can do that without, as it's shown here, without the blower door installed on the front. You can do the total duct leakage test that way. And so you can make the connection to that T connection, and then you can see that blue patch with the brass nipple on it, where you attach that duct work to make the connection to the gauge. You also see there's a 1 inch by 3 inch hole in the ductwork, and now that represents the leakage to the inside. So that's your duct leakage to the inside opening. So you won't have registers to seal like you would in a typical house. You won't have that ability to seal off registers. This will be left open. But you will find we did some testing where we were comparing a total duct leakage test to a duct leakage to outside test, and so during a total duct leakage test, what will leak is air will leak through this 1x3 hole, and then it'll also leak through the hole where the Duct Blaster is connected to. And again, you want to make sure that where this hose connection is on the opposite side of where the white attachment plate is, because this is a more stable area to measure pressure in the ductwork, on the side opposite where the Duct Blaster fan is attached. So during a total duct leakage test, you'll get air leakage through this space, and also leakage from where the square transitions Velcro to the plate. During the the duct leakage to outside test, you'll have the blower door running, keeping this space at the same pressure as the ductwork. And because there's no pressure across any of these openings, there'll be no duct leakage. So if you tape off this opening and tape off, there is leakage through the that Velcro connection. If you tape off that connection, you should get similar readings on your total your duct leakage to outside, and your total duct leakage with those things taped off. So next we'll set up the Duct Blaster fan for the pressurization test, and we'll leave that that zippered opening open during that test. During a standard duct leakage total duct leakage test, you'll want to leave either a window or a door open. And then we'll set up the Duct Blaster gauge. We'll connect the tubing. So previously we showed connecting the tap on the ductwork up to the blue patch there, and then we'll connect the other longer section of blue tubing from that patch to the input on channel A. And what we want to measure is the duct pressure with reference to the enclosure. So this is similar. The gauge is, if the air handler was in your duct blaster is set up in an attic space, you do need to run an extra tubing down to the house. So what you're measuring on channel A is the duct with reference to the house. So we do need to run a tube to the house. And then on channel B, we'll connect the input on channel B to the fan, the Duct Blaster fan itself. So that's our gauge connection. So for total pressurization test, you'll have the flex duct stretched out. You'll have the speed controller connected up. You'll have all the tubing connected up, and you can have the blower door set up or not. You can do that either way. So for total, we're set up for a pressurization test. We'll conduct a 1-point CFM 50 total leakage test using the standard test procedures. We'll pressurize the duct system to 25 and see how much airflow through the Duct Blaster fan it takes to generate a 25 pascal pressure in the duct system. And you can conduct either a manual control test or you can demonstrate the cruise control test. If you're having that leakage outside hole open 1 inch, you'll use ring 3. If you're conducting a test with outside leakage hole to 4 or 8 inches, use ring 2. To do a duct leakage test to the outside, you'll set up the Duct Blaster fan just like we showed in the previous example. Set up the blower door for a pressurization test. Like we did for our blower door test, we use ring C on the blower door. And in this test, you'll completely close the zippered opening on the back of the enclosure, and we'll open that leak adjustment window all the way on the back of the enclosure. We'll connect the tubing on the Duct Blaster gauge the same as we did for a total leakage test. So we've got, remember, we've got duct leakage, the duct pressure with reference to the house on channel A, and then we've got the fan pressure at the flow sensor of the fan connected on the input on channel B. And the blower door will have that tubing connected the same way. So again, we've got house with reference to outside, and because our gauge is outside, we don't need a tube there. And then channel B, we've got we're measuring the pressure at the flow sensor of the fan with reference to the space it's in, and the space it's in for pressurization test in this case is outside. So we've got duct, or we've got on the blower door house with reference to outside, and then channel B is the blower door fan with reference to the space it's in. Conducting a 1-point test of the outside, we're pressurizing the enclosure to 25, and we're pressurizing the duct system to the same pressure, which in this case, in order to be at the same pressure, we'll be looking for 0 on the duct work to house to make it the same as the outdoor pressure. So on the blower door gauge, we're looking for 25 pascals of pressure, and on the duct blaster gauge, we're looking for 0 pressure. We want the ductwork at the same pressure as the house in order to have no duct leakage across that any of those openings. So 0 pressure on the duct blaster gauge. If you're manually, you can manually control the blower door and duct blaster fans, or if you have the newer speed controller for the duct blaster fan, you can use cruise on both of those fans. One thing to keep in mind with the duct blaster gauge when you're cruising 0, or it's same as true with the flow blaster, is you need you would set the gauge to either cruise 0 or -0, and the difference between 0 and -0 is you want to tell the fan on which side of 0 to speed up and which side of 0 to slow down. So if you're pressurizing the duct, if you're doing a pressurization test, your test is going to start out with the duct under a negative pressure, and you want to go past -0 to +0, and then if it goes past +0, it'll start slowing down. So during a pressurization test, you would set it to +0. If you're conducting the test with a leakage window open 1 inch, duct leakage window open 1 inch, you'll use ring 3. If you have it set in the 4-inch or 8-inch settings, then you'll use ring 2 on the duct blaster fan, and use ring C on the blower door fan.